Farid, my colleague, and I are going to chat a little bit about kind of how Cisco looks at automation and how we're building automation in across our platforms, our vision and strategy around this, and what we're integrated with on the Puppet side. Is that what everyone's here to do? If not, this is a great smoke break. There's a bar somewhere down the road. We're good. Looking into this, when we kick off, we are not just as a company, but as an industry, really looking to automate all of the things, right? We're looking to build automation into all of the systems we drive. And this is not just hardware in the data center. This is across campus, across enterprise, and across our application stack. Is that fair and where most of you are looking to go, looking to do? Hopefully, if you're at a PuppetConf, automation is fairly important to you. Now, just by a couple of quick questions, how many of you look at automation as a tool to achieve agility or speed of deployment? Is that a primary goal for automation? A few of you, okay. How many of you look at it for something else, maybe risk reduction? If I build an automated tool, I can reduce the risk of manual change and humans making stupid mistakes, that kind of stuff. That, I think, is of more business value, right? We get agility as well, but I think removing the human touch as much as possible is a good thing. Now, how many of you have worked in systems that have been completely manually automated? Admin 1 wrote this script, admin 2 wrote another, we built this in, we brought in this product, we taped it all together, we had some sort of automation. A few of you? How well did those work? Awesome, awesome, a sarcastic awesome. And if they worked sarcastically awesome up front, they probably did not do so over the long run. And especially as you start to get turnover and people leave, because no one remembers why Fred or Sarah wrote that script or how it actually works. And so, because all of us always document our code correctly, it would be very easy to go back and look at and figure out, right? So when we're building automation platforms, one of the things we've looked at Cisco over the time is how do we automate correctly, build it from the ground up with that intent, and then integrate with systems like Puppet for that automation. Because otherwise you end up with issues like this. And this one turned out to be a hoax, but it was hilarious. It was a help board ask from a guy who ran a 1,000 physical server web server company or web hosting company. And he asked, well, I used Ansible to deploy an RM-RF to all of my servers at once. How do I recover from this, right? So to err as human, to apply that error to 1,000 servers at once is bad automation, right? We need to be able to make sure that we're doing this correctly, we're testing it correctly, we have all the right methodologies around the way we automate, so that when you're testing this script, you don't end up with a non-defined variable that kills you because you tested across 1,000 servers instead of that one test server sitting in the closet or that group of test servers. So we work really hard on how do we build this stuff out. And as we've been looking at this, we've kind of taken a methodology from a little over 10 years ago. How many of you are familiar with the Cisco UCS servers? Cisco UCS servers are one of my first loves of Cisco products. I was an HP and IBM Blade engineer for years, and I got introduced to Cisco UCS, and after I finally kind of got the concept, I never looked back, because it was a platform built inherently with automation in place that actually helped my day-to-day job or my customer's day-to-day job, depending on the role I was playing. So when I looked at that, and you start to look at where that heritage of automation came from 10 years ago at Cisco, we stole it, because if somebody else built it right, why not just copy it? We stole it from the cell carrier networks. If you look at the cell carrier networks, this is a network-connected, network-configured device, and your carrier has hundreds of thousands of these on their network. If they had to come and manually configure this device to get you connected to the network, we wouldn't have cell phones the way we do today. So they made this a stateless device, waiting to accept a state from some other device. So it's a stateless device, does not maintain any of its network configuration, and you apply a SIM card, and boom, you're connected to the network, you have your data plan, you have your cell network, everything works. You go to France and you don't want to pay your carrier's charges, you buy a SIM card from a kiosk in the airport, plug it in, now you've got a new network connection, you're on a new network, you got a different data plan. So in Cisco UCS, we took that concept and we said, why don't we treat servers like cell phones, make them stateless devices intended to be automated up top, and then take a SIM card and turn it into what we call a service profile, logical definition of what that resource should do. And it worked pretty well. Anyone familiar with UCS's launch about 9 years ago? Anyone familiar with the stuff that was said from companies like HP, Gartner, IDC, IBM, or Dell? The unanimous comment, you can go back and Google search history and find, which I love, is Cisco is idiotic for getting into the server business. They'll never be able to compete against HP, IBM, or Dell. They'll be out of this business in 2 years. If you look at it today, it's about a $3 billion business on its own for Cisco, #1 blade server in America, #2 worldwide. And oh, by the way, it's a server with the same Intel processor in it that all of those others sell. Why is it that successful? Because we built automation in from the ground up as a system designed to be deployed in a faster risk or reduced risk fashion. So we looked at that and we said, this is successful, where no one thought we could be successful. And then we took a look at the network. And how many of you have a background in networking, other than the Cisco people in the room? Okay, and in the networking world, if I said we are the most archaic dinosaur in the data center today in the way in which we configure and manage networks, would you agree or disagree? And I know I work for a company that apparently sells a lot of networking. I probably shouldn't say that because we've been selling the same garbage for 30 years. What?
We buy a lot of your stuff too.
You buy a lot of them, okay. I appreciate that, and please keep doing it, otherwise I can't talk and BS up front in people like this because I won't have a paycheck. But if you look at that, we're way behind where technology is today in the networking world. And there's a lot of reasons for that, good and bad, the rest. And my favorite is one I'm probably not allowed to say legally, but you kept buying my crap, so I kept selling you the same crap. Fair enough. But if you dig into it, where you see networking today, networking is some of the most complex archaic configuration commands, all driven by CLI, all box-to-box configured in the network today. Right? If you, any of you Linux admin background? So you really understand Linux, you know all the commands? I knew that was a rhetorical question in this room. If you look at everything you learned to know Linux, if you want to switch over to work on the networking side, you're going to learn about as much to be able to properly configure a network, except it's a whole different set of commands for no reason. Right? That's where networking is today. And that's really bad. Take a look at consumer IT and where consumer IT is today. On the highway between San Francisco and San Jose, you might pass a car that has no driver and it's fully automated, driving down the road very safely, probably much safer than any of us drive. Anyone ever handed an iPad to a 3-year-old and seen how quickly they're able to use this thing that has more technological power than we use to put a man on the moon, and they can immediately figure it out and use it? That's where consumer technology is today. And then you go back to the network. Anyone ever configured quality of service or QoS for a network? To configure quality of service or QoS for a network, you break out an encyclopedia about this big of QoS codes, and then you figure out which codes you want to use, and you go to each device and you type in dozens of very archaic commands to put those codes in place, and you go from device to device all across the network you're trying to apply quality of service, and oh, by the way, if you make one typo on one command on one device, the entire QoS system does not work, and that is networking 2015. Got to get away from that. So we said, how do we do that? Well, why reinvent the wheel? UCS worked, let me build it again for the network. How about I build a stateless pool of network resources, switch the word server for switch, or switch to router if you want, and then instead of a service profile, I use an application profile. You define or describe what your application looks that you want networked, and from that profile, I will provision the network as a whole system. Does this theoretically make sense? This is provisioning and automation based on policy, and this is the way we look at the world. When we take this a little bit further, we also are starting to understand where we live. I know my colleague Farid likes to talk about Cisco in 2000 was one of the most valuable companies in the world. You know why we were one of the most valuable companies in the world in 2000 or not one of the most valuable companies in the world in 2015? Is it 2016? Sorry, I drink a lot. It's because infrastructure is not as relevant as it used to be, and it was absolutely relevant in 2000. We are less relevant, and we're starting to realize that. There's a little bit of ego attached to us, so we have to, it takes us time. But when you start to realize that, I'm just one pin in the wheel here as infrastructure. Above me, you've got things like Puppet, which is an automation framework, which lets you provision what I do faster and with less risk. And then you move up the stack again, and you look into the actual software processes. And how do I take that software architecture and build in processes to rapidly develop that software? And then getting up into the top, how do I automate those software processes? And this is the big stack we have to build, and it's tools like the right infrastructure tied into management frameworks like Puppet that help us get up to that application stack, which gets us to that agility. Are all of you looking to have a more agile response from an IT delivery perspective? Is anyone not looking for more agility, more speed? If you are, you probably want to start studying for another career. Or if you aren't, you probably want to start studying for another career. 7 years ago, in a conversation with a CIO, 100% of the time, their primary concern would have been return on investment. Joe, how much can whatever you're selling save me to do the exact same thing I'm doing today? 100% of my conversations today with CIOs is the opposite. I am willing to spend more money, maybe not exponentially more money, but more money if you can get me faster, and get me faster without increasing my risk, and get me faster without increasing my security vulnerabilities. Is that fair? So that's where we want to look, and that's where we want to build. But there's a few things we have to do up front. When we look at this a foundation. We're pouring concrete. If you build a house on the beach and you start with the framework and you didn't build concrete underneath for a foundation, you're not going to have a house very long. The foundation is extremely important. How many of you buy into the idea that you can buy any cheap off-the-shelf hardware as long as your automation systems and software systems above are built correctly? Okay. 1, 2, and feel free to say it, right? So that is a big push in the world today. There's a lot of people talking in IT about that. There's a lot of talk about white box and server, white box and switch, white box and the rest. And I'm not going to argue that point completely, but in my personal opinion, I disagree wholeheartedly. And the reason is, if the hardware underneath isn't good enough to support what you need, you're not actually going to be able to run it in a resilient enough fashion to keep everything else up and running. And I'm not alone in that thinking. Facebook doesn't believe in any hardware under the covers. Google doesn't believe in any white box hardware under the covers. Both of them specifically design the hardware that they use. Facebook's actually built the community of Open Compute platform, which is now also an open network platform, to specifically design systems that are open. You can buy them, you can get them cheap, but they're designed for what they require from their data centers, right? Google does that for their own on the server side, on the switch side, and the rest. They get them cheap because they buy more per quarter than you do in the 10 years, right? And so they get economies of scale. The hardware underneath matters, and there's a lot of places where it absolutely matters. When you look at this, the infrastructure that I build has to be able to support a few things. And traditionally, it wasn't designed to do that. I'll use networking as an example because it's probably more near and dear to my heart right now. If you look at a network switch that was bought or sold for the last 20 to 30 years, what was its primary interface, the primary exposure to the world of a network device for management and configuration? CLI, command line interface, right? And our network engineers love the CLI. Spent a lot of time on it. They probably don't even want to leave it because every time we've tried to give them a GUI, we wrote a crappy GUI and it didn't work, so they got tired of GUIs. But when you look at that CLI, a CLI is a human interface. So you have a machine, it's primarily designed to be interfaced by a human, somebody typing on a command line. Now look at automating that. Anybody ever try to do automation through SNMP? A very crappy attempt to be able to build automation into a device designed for human interface, right? It doesn't work. Anyone worked with a device that was primarily CLI driven, but they realized that the world was moving on, so they wrapped an API on top of it. So now you have an API that exposes programmatic commands to a CLI for a human interface programming machine underneath. Did those work well? Typically not, right? What ends up happening is you have a language translation problem at that point. What you have is your automation system is a machine, and that machine speaks German. And then you have a human interface that speaks Italian, and then you have a machine underneath that human interface is programming that speaks French. And so you have to find a way to translate these languages, multiple layers all the way down. And if you've ever tried to have a conversation with somebody who speaks a language you don't, and they don't speak yours, it becomes very difficult. Now, if you try to do that 3 layers up, that becomes even further. This is why every network management system ever built to date has been a pile of garbage, because it's working on a system not intended to be managed by anything other than a human. So what I am saying here is that you need hardware and software that's primary intent is to be programmed, and if it is exposed via an API, which is the traditional way to do it today, that API be the native exposure, not an afterthought, not a tack, not a shim, not a piece of duct tape. Right? Otherwise, we run into problems, right? You want to be able to run your Puppet agent directly on the device in the operating system, whether it's a switch or a server or whatever else. And if your hardware vendor or your operating system vendor or whatever can't do that, you're not going to be successful the further up you move or the larger you scale. That fair? So that's what we focused on. That way we can plug into these management frameworks and we do it correctly. There was an interesting thing when we first started looking at working with companies like Puppet. We have automation built in inherently into ACI, and we have automation built in inherently to UCS. So why would we work with Puppet? Because they're doing a similar thing to what we are, but on our systems. It's really easy. If you want to automate your entire data center, I seriously doubt you want 15 different management platforms to do it. So if you're already using Puppet for your servers and you're not using my servers, and you want to use it for my network switches, which fully support it today on the Nexus 9000, 3000 platforms, and the others getting it over time, you don't want to just use my management infrastructure. You want Puppet to be able to integrate with what I already do. And so that's what we're building out. I have a pool of resources that's already inherently automated, but I can take a Puppet manifest, have that actually deploy what my system does. Right? That's the way we're building it out, and that's the way we're building a much more open Cisco than we have probably done in the past. Anyone heard of Cisco as the big closed proprietary company? Okay. That's what we're trying to get away from. When we look at this, the next step is the framing, right? You've got your foundation, everything's solid, you've got a place to start building, now you have to frame this house, and when you start to frame it, this is the frameworks like Puppet. This is your automation system. This is where you're actually moving up the stack to provide more value to the business that you serve as an IT practitioner. This is where we need that infrastructure to natively support the agents, to be able to integrate with it without an extra shim. The more shims or layers of duct tape you build into any given system, the more trouble you're going to have down the road. There's a few other things that are going to always help you automate. standardization. And I'm not necessarily saying buy all Cisco gear or all Dell gear or anything like that, but the less different vendors, different types of hardware, and different types of operating systems you use, the easier automation, orchestration, private cloud is going to be. Right? So the more you can reduce down to what you need and make sure the native capabilities are there, the better off you'll be. And then the next piece is orchestration. I'll tell you two secrets about me that aren't very secret. I'm a raging alcoholic, and I have no personal life. So 10 years ago, I spent all of my time arguing in bars with other IT practitioners whether by 2015 everyone would either be in the public cloud or the private cloud. Funny thing looking back is myself and everyone I argued with was dead wrong and moronic for whatever we said during the conversation. Do you know where everyone is today? Both. 54% of customers today are using both public and private cloud resources. 80%, if they're not already using them, if you take that 54%, the rest up to 80 are planning to do so. You know why? In most cases, both make sense. There are use cases for both. Cisco IT runs one of the largest, most advanced private clouds in the world. Cisco also utilizes Salesforce.com as a SaaS model and Box.com for our file sharing because they make sense and they blend in. So we need tools that can help us orchestrate these systems together. And when we look at these higher level tools for orchestration of public and private, and I'm not going to use this word single pane of glass, because every single pane of glass system I ever used, you should change P-A-N-E to P-A-I-N. They've never worked out correctly. But when you look at this, I need my orchestration system to tie into what you're already using, which again, if you're sitting here, is probably Puppet. So we purchased a company called Clicker, which is now Cisco Cloud Center, to do this hybrid cloud management. And it has the ability to tie into the automation frameworks like Puppet you're already using. We take a look at this, and prior to the last year, I was a principal engineer helping to design and bring these products to market. And then I built this slide for a slide deck, and my boss saw it. And my boss took one look at it and laughed at me, and then laughed some more. And he told me no self-respecting engineer would ever build a slide like that. You're now a full-on marketeer, and you're fired as an engineer. I'm going to give you a director title, and you can enjoy dead weight middle management. Paycheck's a little bit better, and your value to the company is a lot less. And I said, fine. So that's where I am today. But this is the way we've looked at automation frameworks and the way we do things. App agility is what I need to be able to provide. I need to be able to provide you the ability to deploy applications and services as fast as the business you work for demands them. Because competition is fierce now, and technology is the way companies win and grow. App agility is a vision. Mario Mazzola was our executive. Mario Mazzola is a pretty impressive human being. He just retired at 71. His first claim to fame was he was the guy who founded the company that built the Catalyst, the original Catalyst switch. So he built the switch that was an Ethernet switch when no one was talking about Ethernet, and today it's a $30 billion install base, most successful switch on the market. He's been doing this stuff for Cisco for quite a while, and he has a quote that vision is for amateurs. Execution is for the professionals, right? App agility was our vision. This is this hard stuff we had to do to be able to execute. First, if we look at a system, to be able to automate it correctly, to be able to build it up to the next level, the first thing you have to do is simplify it. And on the networking space, this was actually far harder than I think it was on the server space. As network engineers, we've spent 25 years building more and more complexity into the network. Everyone remember the old 80s TV show MacGyver? Okay. MacGyver was the gentleman who could fix any problem, solve any situation with whatever he saw laying around the room. So he could take duct tape and bubble gum and fix anything that you threw at him. Network engineers are MacGyver. The only difference is they call duct tape IP, and they call bubble gum spanning tree protocol, and they patch everything you throw at them with those two things. And so we have really complex networks. Anyone familiar with the CCIE exam? Could be considered the pinnacle of networking exams. Very difficult exam. You spend a lot of time and a lot of money in the industry studying and going through, and then you take the written exam. And if you pass the written exam, you get the privilege of spending about $3,000 of your own money to fly somewhere and take a lab exam. And once you fly there, you spend 8 hours taking the lab exam, and guess what happens? You failed it. You fly home, you cry, you drink a few beers, and you study some more. And you fly back and you take it, and if you're lucky, you get it the second try. And then you go on to the third. 15, 20 years ago, there was one CCIE track, one way to go, route switch. Today, there are 7 different tracks at that level. Should it, in 2016, require that level of knowledge to operate a network on a day-to-day basis? No. That is absolutely insane, but that's where we sit today. It's 2016. I should basically be able to put a chimpanzee in charge of the day-to-day operations of your network and have it be okay. When it needs to be troubleshot or re-architected or rebuilt, or I need to design hardware, that's where I should need a CCIE. That's where we're trying to take this, and that's what we built out with our application-centric infrastructure, or ACI. We also have to start looking at central provisioning of a network. Networks were specifically and intentionally designed not to be central systems for the purpose of resiliency. They were designed for military specs. When you do disaster recovery for your businesses, you think about my data center goes down, this rack goes down, this power supply goes down. When the military thinks about disaster recovery, they think about New York and LA just disappeared. Right? It's a little different level of resiliency they worry about. So what they wanted to do is, if New York and LA disappear, how does the network recognize that and continue to route around that, get packets moved, continue connectivity? So they built each device independent, so it could recognize its neighbors, figure out what it needed to do, and route around. So we specifically decentralized them up front. We need to find a way to not break resiliency while centralizing the management and provisioning of them again. So if I go back to my QoS example, you don't have to go to every device and type in all these archaic commands and then hope you didn't make any mistakes. Instead, you tag an application like video that has specific requirements, that it's video, and that it has those requirements, and have a network smart enough to consume those at any device it touches. Does that make sense? So that's the type of systems we're building out. And then finally, as I got to earlier, I need a foundation of hardware and operating systems that are designed for automation and programmability. And I'm not here to say that I'm the only person that can do this or the only company that can do this. I'm saying that is what you need, and I do actually. We do that with our products. Any of you HP server users? Or HP Blade users? A few of you? So when we launched UCS, obviously HP's got some good quotes on the fact that they didn't think it was going to compete. Most of the market share we've taken over the last 9 years has actually been from HP. IBM got tired of competing and they sold x86 off to Lenovo. But HP this year will release a Blade chassis that will actually be able to, on an automation level, start to compete with UCS. This is 9 years after UCS launched. To be able to go to that model, guess what you get to do with your existing HP equipment? You rip and replace every piece of it. Because over the last 9 years of trying to build in the same level of automation into the existing HP servers, they realized it can't be done. It has to be the first thing you think of as you design the system. So even they agree with us theoretically, even though they wouldn't admit it. When we look at this, what we want to do is get rid of the silos in the data center, right? And this is something you're already looking to do with tools like Puppet. Puppet was, if I'm correct, originally just a server tool, or primarily a server tool. Right? And now it's a network tool. Now we're using it all across the board. We want to get rid of these silos because the silos create risk and the silos reduce agility and speed. To do that, everyone's looking at automation. The difference in vision between my automation and a lot of the other automation tools is that we focus on what I call, or what we call, policy-based automation. I don't want to automate based on engineering terms. So for example, any automation tool off the shelf, I could very easily tell it, provision me VLAN 20 on switches 1 through 15, and it would go provision those. Fine, easy. I could do that with Notepad, to be honest. Not very hard. I don't want you to think about VLAN 20. I want you to think about, I have a security requirement that needs this segment for this application. Business level logic around an application. That's what I'm calling policy. And so when you define the security requirements at a business level policy level for an application, my system should be smart enough to interpret that and provision underneath. Which means at the end of the day, if I need VLAN 20 on 15 switches, same end result, you just didn't spend that time converting business logic to technical provisioning yourself. The system does it, shows you what it's going to do, and you okay it. Is that fair? Is that theoretically a good approach? So that's where we've looked at our data center portfolio. And then originally we looked at this as a data center strategy, and Cisco's data center strategy is very rapidly changing. Cisco has been fumbling for a cloud strategy for about 10 years. Every 6 or so months we go out and we say we have one, and then every 6 months we completely change it and say we have another one, then we bring on a new CTO. He stays around for 13 months, says we have one, then we fire him. Somebody else comes in. I don't think I was supposed to say that. We finally do. The strategy is that the application and service delivery that we have to deliver as IT practitioners today does not stop at the data center walls. It may be public, it may be private, it may be colo, it may be anything. So we need a way to provision this all together. How do I give you the ability to tie your private cloud stack and not care what's in here? Maybe you're using Cisco UCS Director and you're using ACI and you're using UCS. Maybe you're using VMware vRealize, maybe you're using OpenStack, maybe you're using Puppet, maybe you're using whatever you want. Right? How do I tie in whatever you use as a private infrastructure, tie it to the public resources you choose? And while I'm doing that, provide consistent enforcement of the policy at the application basis level, provide a portal that lets you manage these with one operational model so that you can see your public resources and your private resources, so that you can do things like one of my customers is doing with our Cisco Cloud Center product. They're a software as a service provider that built their entire business in Amazon EC2. And they got to a point where they started looking at their costing and they're paying way too much to Amazon. It is costing them too much and they're losing their margin, their profit. So there's two things they could do. They could start to look at building out private infrastructure for the first time, and some people do that. They come out of public to private for cost reasons. They don't want to run their own infrastructure. They never have, they don't have the staff, they don't want to do it. So they looked at other public clouds, and apparently today, Azure can cost them quite a lot less to do the same with the same capabilities they need. So they need to move to Azure. Anyone ever done a public cloud migration, moving an app or a service from one cloud to another? It's miserable. Each one speaks a different language. They expose their proprietary API, and that's how you build your application on it. So if you're going to move from Amazon to Azure, you're almost rewriting the app to be able to do it. So they're using tools like Cisco Cloud Center, so they're going to have the same pain moving to Cisco Cloud Center as they would moving from AWS to Azure. But they're going to do it once, because what Cloud Center does is you model your application into Cloud Center, and once it's there, it abstracts the API of 19 different public clouds and any private cloud resource you want to use. So now I have an automation tool for the application, and if you put it onto AWS or Azure or Google or move it week to week, you don't have to rewrite anything about the app because that is abstracted and the Cloud Center technology is doing that for you. Right? And so that's what we're building out. Policy everywhere, security everywhere, and analytics everywhere. These two are really difficult. The tools Amazon uses to secure are different than Google's, are different than Microsoft's, are different than VMware's, are different than mine. The actual implementation of security is very different depending on your architecture. What we're building and what we want is automation that says, this is my policy at the application level. Security, compliance, geo-dependency, whatever it may be around an app. And when you deploy that, I'm going to abstract the infrastructure underneath. So the same end result gets applied, even though the infrastructure deploys it in a different fashion. Does this make sense so far? Any questions so far? Yes, sir.
What are the different cloud providers that you're supporting?
From a Cloud Center perspective, the ones I know off the top of my head would be Google, Azure, EC2, and SoftLayer. But there are several others, and we have Mr. Jiandani and Ms. Stoughton here in the room who can answer that offline afterwards. Can probably give you some more detail on the rest of the cloud providers. Okay. So this is what we're doing. The last thing I'm going to talk about here is the analytics everywhere. This, I think, is the most interesting thing you're going to see coming out of Cisco in a long time. Both of these things are what I would call provisioning of intent. I'm going to automate based on your intent of the application, right? You tell me what the policy is, that is your intent for that application, I'm going to provision it. If I told you that my automation systems were provisioning your intent, would you be doing your job if you just trusted me at my word? I'm a very untrustworthy person, so you should probably be shaking your head now. You need the ability to verify, right? Anyone ever been to Missouri, St. Louis, something like that? It's the show me state, right? They're not going to believe anything. You have to show them. You have to prove it. In the Marines, we used to call it trust but verify, right? I need a way to be able to show you in real time that what you provisioned on day 0 is actually provisioned, and it's provisioned the way you expected it. But more importantly, on day 15 or 50, show you that it's still provisioned, that some administrator didn't make a mistake, that some automation script didn't change something it wasn't supposed to, or that some malicious attack didn't change something, and so now your policy intent is no longer being followed. And we'll talk about how we do that. The other thing that we've done, and I talked a little bit about this earlier, is Cisco has had a reputation in the past for being very proprietary, and we really want to change that, and we've been focused a lot on this in a lot of different ways. We want you to build private infrastructure with the right tools at the right layer, regardless of the logo on that infrastructure. So if I have a product at any given one of these layers, I want you to buy it because it's the best of breed in that product and it works for your business. I don't want you to buy it because you bought one of my other products and it works best with that product. You understand the difference there? So when we look at this, my server platforms, my network platforms, ACI and the rest, are a foundation. If you choose another SDN solution because you're primarily a VMware shop and you want to run VMware NSX for some other piece, great. put it on top of my network, put it on top of my bare metal switches, put it on top of my ACI solution. I'll integrate with it, I'll support it, I'll run it. I don't need to compete on that. I want you to pick the right levels. I'll integrate with anything. If it's Linux containers, if you're looking at microservices, if it's any type of virtualization, we treat it all the same so that you don't have to have a different solution for every workload type you have. And then if you want to work with bare metal, because all of us still have bare metal, and if you're looking at big data systems, you're going to have more bare metal, then we integrate with that just the same. And if you get to the orchestration and automation layers, and you're using frameworks like Puppet, and you want to use frameworks like OpenStack, great. I don't have to force UCS Director down your throat because it has a Cisco logo on it. I integrate with all of these the same way. When we look at this, we also had a focus on security, and I know there's been some great talks here. I know Rob's been giving a bunch of great talks on DevOps and security. Have any of you sat into those? If you haven't, you missed out. Go back and watch the videos. But 5 or 6 years ago, when people were talking about DevOps, nobody mentioned security. It was all agility. How do I get faster, code faster, release faster? The problem with just releasing faster is you're creating vulnerabilities faster. If you're not thinking about security while you're building agility, you have a problem, right? So when we built these systems, when we built our automation systems into ACI and the like, we looked at security. So first we looked at how do I make the network as secure as possible. And we've done a lot in there. If you ever want to find out about it, we can talk about it. But when you look at that, that's one piece of the puzzle. The network is a very small piece of a security architecture. Software has to be included. You have firewalls, IDS, IPS, all kinds of other security devices. So we needed to build a way that if you're provisioning based on application policy, and you're provisioning this across through integration into things like Puppet and the rest, that I can also provision out your security elements. I can provision that firewall. I can provision the IDS. I can provision the IPS. This way, when you provision an application, you do it agile, and you do it fast, and you're doing fast release, your security device is also coming along with you. The other thing we did here was actually very hard for us to convince Cisco's executives when we made the decision to do it. On the left side of my slide, you're seeing some very competitive logos to Cisco. Checkpoint and A10 are direct competitors of Cisco's. They are completely partnered and integrated into our network automation system, even as direct competitors in the firewall security space. The reason being, I cannot expect you to buy all Cisco products for security. So I need to make sure that I help you automate your entire security ecosystem, even if I didn't get your wallet share on that particular security product. And I think this is one of the most important things we've done as a company recently. There's a logo that's not on this slide. We are fully integrated at the same level as any of these with Palo Alto networks. Any of you using Palo Alto today? No. We're fully integrated with them. The funny thing about them, and the reason their logo is not on the slide, is they are one of the most anti-Cisco companies I've ever worked for. They hate Cisco passionately. Right? And they're not the only company. There's plenty of people that hate Cisco passionately. That's fair. I hate Cisco passionately. The mic's not on. Good. So Palo Alto, when our former CTO, Padmasuri Warrior, did the negotiations with Palo Alto around the partnership and agreed to our engineering working with their engineering to get them in and build a device package to automate their devices, their CEO finally said, sure, we'll do it. We'll build it. Our engineers will work with you. We'll support it. But you'll never use our logo. We'll never use your logo. There will never be a joint press release. If by word of mouth our customers know that we have the integration, they can call us and we'll give them the integration. That's how anti-Cisco they are. But we're still partnered with them the same way we are with our own products. Anyone big followers of Gartner? Two. You love them? I've been told by our legal team repeatedly to not say the comment I'm about to say, but I really don't like to follow the rules much. I hate Gartner passionately. I find that the only thing that they ever do well is tell us exactly what's going to happen in IT 3 years after it already starts happening. But beyond that, I haven't found much use. Gartner right now is talking a lot about bimodal IT. Anyone heard the conversation around bimodal IT? Bimodal IT is interesting to me. Conceptually, it makes a lot of sense. We have a lot of archaic siloed applications that are going to be very difficult, if not impossible, to move over to a mode 2, agile, microserviced, whatever you want to call it, model. Is that fair? Where we want to be is in that faster model, where we can deploy, we can release, we can deploy, whatever you want to do. So Gartner says instead of trying to take everything from mode 1 and put it into mode 2, just run 2. Run a mode 1 side, where it's all your legacy stuff, and keep care and feed for it and keep it stable, and then run a mode 2, where everything's agile and happy and it's unicorns and rainbows. The problem is the way they describe this is really running 2 sets of infrastructure with 2 operational models, and typically 2 operational teams is the way they describe it. They're molding that differently now, but that's the way it originally came out. And I always put myself in the shoes of the CIO that has to sell that concept to the CFO and the CEO. And that conversation in my head always went something like this. Ma'am, I've been running your IT department for the last 5 years, and it turns out I got it all wrong. I have this really slow, archaic beast that can't meet your current business demands anymore. So I asked my engineers to look at it, and they took a look, and ma'am, they can't fix it. So I'm going to have to keep carrying and feeding for all that because it's our core systems, it's our SAP, it's our ERP, it's all that fun stuff. But to get you the agile for the new stuff, what I need you to do is double my budget so that I can invest in a bunch of new hardware and get some new people to run that. And I'm going to run a really fast agile mode 2 operation on the side. And trust me, I'm going to get it right this time. Any of you think a CFO and COO are buying off on that? Probably not. So what's that? Is that really? That's what you're doing?
Yes.
That's what you're doing now?
That's what everyone does. Every bank. You can get to any bank in the world right now. They're doing that right now.
Well, shit. All right.
You get the
I mean, I love it because I get to sell the infrastructure twice, but I look at it as if you're doing that now, there's got to be a better way, right? Instead of running 2 separate modes on 2 separate infrastructures with 2 different operational models, why not get systems that are designed to do this? If you look at UCS, ACI, the system Cisco has been building in the data center for years, we build them with multi-tenancy in mind. And most of my customers go, why do I need multi-tenancy? I'm not a service provider. And I say, you look at it differently. Look at the tenants as business units, or in this case, look at tenant 1. I can carve off your silo, give you separate administrative, separate security, separate stability rules here, and then give you a mode 2 that's running over here on Puppet and OpenStack or whatever you want with a whole set of different boundaries on one pooled set of resources with one operational model. And then I give you another thing that I think is the most important. How many of you are absolutely religious in your environments of decommissioning hardware and recommissioning it if it still has value when an application gets decommissioned? One hand, right? And if there were 200 people in the room, I'd have 3 hands. We're not typically very good at that. When you have systems that are built like this, as soon as I decommission an app over here because I was able to rebuild it in an agile model, the resources are automatically released and available, right? So I don't have to go through a manual process. Or maybe you're looking to get more agile, but you're not looking to invest in more infrastructure. It's fair. I don't like it because then I don't get paid, but whatever. So now you look at things like Cisco Cloud Center. Now I can keep a single automation model, put all my mode 2 in the public cloud, get cost back, get charge back, get plugins to things like Jenkins for my software release cycle, get it all in one portal, so now I can manage it in one fashion and be able to do all of these things. Our big picture vision when we looked at this, we were actually set out as a separate independent company, NCMA Networks, and I joined them 4 years ago. John Chambers gave us about $185 million of Cisco's money, small chump change. He gave us 4 years to build an SDN, or sorry, 2 years to build an SDN product and bring it back to Cisco. And as we were building an SDN product, we realized one thing. SDN is 100% irrelevant. SDN is a simple cog in the wheel. It's automation for the network, right? That's really the idea of it. In fact, if I get SDN absolutely right, you forget the network's there. That's the purpose, right? We looked at that and we said, what's the real big picture? And that's when we realized that you're all using both public and private resources. So that's when we convinced Mr. Robbins to acquire Cisco Cloud Center and or Clicker and brought them into Cisco Cloud Center. And then the final piece was, how do I give you visibility into this? These are my automation tools for deploying these. These are the tools that plug into the things you're using like Puppet. But how do I then give you real-time visibility on the back end? And we set out a team to build that. And that product was announced earlier this year. It's Cisco Tetration Analytics. Tetration, if you look it up on Wikipedia, you'll find about 10 pages. It's a scientific formula. If you boil it down to its smallest parts, we hired a couple of the people who had originally helped with Google search algorithms to build this product, and they had some egos attached to them, so they wanted to build a product bigger than Google. And so Tetration, if you boil it down to its simplest term, means a number bigger than Google. And that was the original code name for the engineering work, and then at some point one of these slides got sent to legal. Legal went through and said, oh yeah, that name's fine, we can do it. No one else is using it, put their stamp on it, and once legal said their stamp on it, now it's a public name. So Tetration is an accidental release name. It was not marketing driven. That is a piece, I'm gonna skip this because it's garbage for right now. What that allows me to do is take sensors that sit within your operating system, sensors that sit within your network devices, and pull data at real time. Anyone ever tried to pull real-time flow data from a network switch? It's fun, right? You cook the CPU, switch goes down, nothing works, right? So we built real-time sensors into the network switches, so I can look at everything that crosses that switch without a performance hit on the switch, and I can export the metadata about the traffic flows. And then we built operating system agents that can sit there very lightweight and highly secured so that I can look and tie back the connectivity map the network tells me to the service that was kicked off, who kicked off that service, what time they kicked it off, and what CLI command actually kicked the service off. And then we built plugins for Active Directory and DNS and DHCP and CMDB so we can make that human readable. So now you know this is Joe.com running on this Apache web server, kicked off by this service, by this CLI, with this user, with these privileges, and this is the things it connects to across the board on these TCP and UDP ports, and doing this all in real time. Now, if you were listening to that auctioneer speed babble, then you're probably wondering how you process that amount of data. And it very quickly becomes a big data issue. So when you get a big data issue in today's world and you really want to solve it by building a product, you have about 30 human beings to choose from to help you with actually building a big data system from the ground up. Is that fair? Like worldwide, there's about 30 people who can actually build something from scratch in the big data world. So typically they work for Yahoo or Google, so we hired a handful of them. And what we built was a big data system. This big data system can provide real-time analytics and under 10-minute actionable insight onto all of that data flow coming in. And so when I start talking about this, I'll get into what it does. But when I talk about what Tetration is doing as far as real-time visibility in your data center and next year into your public cloud resources, when I talk about ingest, I talk about, with Tetration, hundreds of thousands of transactions per second ingested. My competition in the space, if I have competition in the space, they talk about thousands of transactions per second. When I talk about record storage, I talk about billions of records stored. They talk about hundreds of thousands of records stored. When I talk about searching and finding usable information on that stored data, I talk about response times of 20 seconds on billions of records. They talk about response times of hours on thousands of records. Right? This is a very fast, custom-built big data system. And what it provides is some interesting things, and the one I want to talk about primarily here is application dependency mapping. How many of you are focused on looking at and dealing with things like DevOps? How many of you are focused on your application delivery cycle and continuous integration, continuous development, that kind of thing, the application layer? How do you do that if you don't know all the applications running in your data center, what their dependencies are and what they connect to? How many of you are trying to migrate applications to public cloud when and where they make sense? You know what the biggest failure I see my customers when they try their first public cloud migration is? Stupid dependencies. I take a 3-tier web app and I think it'll look great in Amazon, so I take web, app, and database tier and I put them up in Amazon, turn it on, and it fails. Forgot about Active Directory, forgot about DHCP. Oh, by the way, it connects to this NAS storage over there. That type of stuff. So the first thing the system does is build you a full real-time application dependency mapping that stays up to date in real time. And then how many of you are looking at enhancing your security and looking at terms like microsegmentation? I do microsegmentation. I have competition that does microsegmentation. You start to look at microsegmentation, there's a fun thing. Microsegmentation is a tool that gives you the ability to put in far more granular security rules down to the VNIC level if you want. It doesn't tell you what to put in there. Most of us can't manage the firewalls and security rules we already have, so how do we figure out how to get more granular? Oh, well, once I get you an application dependency mapping and your team verifies it and says, yes, this is the proper connectivity, I can flip it and tell you this is all the stuff you can close down at the most granular possible level, down to TCP UDP port to the server or VM. We call it nanosegmentation because we always have to reinvent the wheel with stupid marketing terms. Skipping on a little bit, the other thing the system does, and the last thing I'm going to do as I close, is as it's ingesting all of this, you may get multiple transactions, or multiple copies of the same transaction. I'm looking at server OSs, I'm looking at the network. I theoretically could get 2, 3 copies of the same data. So what it does is it deduplicates that, and it stores one unique copy of every transaction on your data center down to the disk. And we're only talking about metadata. I don't look at payload, I don't look at all the other information, so it's a minuscule amount of information, big data cluster, scale out, so I can store a lot. So we can store billions of these records. You now have a historical record of every transaction that ever happened within your data center space from the time you deployed Tetration. This gives you some really cool abilities. Our marketing team, in their brilliance, calls it a time machine for the data center. Yay! I look at it a little more like a DVR, right? I'm storing all this stuff, I'm recording your live TV as your data center traffic. But I do some interesting things that a DVR can't. So one of the things I can do is what a DVR can. Let's say you're watching the football game, and touchdown gets scored by your team, and you're happy, but your beer wasn't fresh, so you hit pause, you run in, grab a beer, roll it back, watch it again, take a sip. Right? Great, that's what a DVR does. I can do that with your data center. You think you had a breach Christmas Day last year? Go back, play all the transactions that happened Christmas Day last year, and I'll start red flagging anomalies. You don't typically use that TCP port. You don't use that packet size. Those two groups of objects don't typically connect. Start looking there. But what your DVR at home can't do is if it wasn't your team that scored the touchdown, you can't hit pause, grab a beer, and say, play it back as if they'd gotten tackled on the 1-yard line. With this, you can. I can go and look at security modeling. So one of the biggest issues with security modeling in the past is security teams have to take a guess at the rules they can put in place based on the knowledge they have. They get a change window, they put it in place, they make sure everything's still up and running. If it is, great, leave the change. If not, roll it back, wait for the next window. With Tetration, they go model the change in Tetration, hit the button. I do an impact analysis against the historical records that ever crossed the data center. Tell you, if you put that in place today, this is exactly what would happen. Red light, green light, yellow light. So now you can logically verify prior to doing an actual production rollout. And this is the kind of stuff that allows you to move fast with tools like Puppet in the automation space, with tools like DevOps, with methodologies like DevOps, yet still have the visibility that what you intended to happen happened and is still in place moving forward. Fair enough? All right. Well, thank you very much for your time.